Okay, so we're in the middle of making the transformation here. So this inverted triangle, since this is in this point, its x is 2 and y is 0. So x minus y and x plus y are the same. So basically this is going to land on the same point x is going to be. So I'm making here the picture of the inverted triangle. Go to this chart, you see the triangle is right there. Next, how about 0, 0? Also the same. How about we'll go to this point here. This is going to be a regular triangle. See by the point where x is 0 and y is 2, there's a regular triangle. So here x minus y is negative 2 and x plus y is 2. So the u is the x plus y is 2 and the v is negative 2. You see it here, it's on this place there where it's 2, u is 2 and the v is negative 2. That's where that point landed. So this is just to get a rough idea what we're doing, but let's go more deep into this. What's happening here is basically more fundamental. Here we had in a 2 by 2 square, we got all these points. Here these points are taking off a 4 by 4 by 4. Actually 4. Why? Because in this area here, you have to realize that we can generate x plus y can span anyway between 0 and 4. On the other hand, x minus y can be anywhere between negative 2 and positive 2. So let's see something here. Can we have a point, for example, 4, 2? Can that be such a point? No, it can't. We cannot have x plus y should be 4 and x minus y will be 0. How can you have a point that can be called 4, 1? Also not. Automatically, if it's 4, it must be 0. So we see here that this graph is not 100%, does not have the whole area. I'll show you where this graph could go. It can go anywhere Here you go. Let's take an example. Let's ask a question. This shows that the graph goes in a slant. The UV graph doesn't cover the whole area. For example, how about we want to have a point that's called U would be 2 and V would be 1. 2, 1. It means x plus y should be 2 and x minus y should be 1. Let's see if such a point exists. So we write down the equation and we do some algebra here. We want x plus y equal to 2 minus y, that's going to be the v point, is equal to 1. So what's x and y? We have to convert this point. Now we're working backwards. If we want the point of uv should exist, that u should be 2 and v should be 1, it means x plus y should be 2, x minus y would be 1. So what is x and y? For this we do algebra. If x plus y is 2 and x minus y is 1, it means 2x is equal to 3. So x must be 1.5. If x is 1.5, so y is 0.5. So is there a point 1.55? Yes, there is. So now we see already where we're heading at here. The first job is to find out what is the area where this thing covers this thing here. It can only go on a certain place. Once we know that area, then we could try to figure out each point Okay, so how do we go about this? So what we work first, we work the opposite way. If we say u is equal to x plus y and v is equal to x minus y, let's say what is x equal and y equal, and then we'll see how we work around. So if u is x plus y and v is x minus y, so u, this so simple algebra will tell us that u is equal x is equal to, so 2x, so u plus v is 2x, so x is equal to u plus v over 2, and y is equal to u minus v over 2. To check if the xy point exists, we take u plus v over 2, u minus v over 2. If that point is not included, we cannot make, so we take all the uv points, and we see, we're going to work now the opposite way. What we're going to do is, we're going to make a uv chart, and we'll see how does that coincide with the chart. Just the opposite like we did, because this is going to make us show how we have to focus more on the UV chart. What we're going to do is just the opposite now. Please bear with me because this takes time to get